Okay, so we're talking about quadratic functions and their inverses. The inverse of a quadratic is the square root function. So in purple we have the positive domain of a quadratic function. In orange we have the complete domain of the square root function, and in green we have y equals x. So the purple one is x squared, the orange one is the square root of x, and the green one is y equals x. So you can see they're completely symmetric. Now the problems arise when we have the domain restricted lifted off of the quadratic function. Alright, so here we have this entire part of the quadratic function that's not being reflected across this y-axis. So in order for a function to be invertible, it has to be what's called a one-to-one function. A one-to-one function is a function that passes the horizontal line test. It has only one y value, or it has only every x value is associated with a unique y value. We know that a function passes the vertical line test. A one-to-one function passes the horizontal line test. Now, the square root function is not really defined in the real domain, in the set of real numbers, in the negative domain. So, if you are presuming to only work with real numbers, this looks like, the square root function looks like it is a one-to-one function. The quadratic function in purple is not. It fails the horizontal line test. If we pass a horizontal line through it, it will hit it twice. Okay, so is y equals x a one-to-one function? Yes, it certainly is. If you pass a horizontal line through it, it will only hit it once. Let's try the absolute value of x. Is that a one-to-one function? No, it fails it is a function. It passes the vertical line test. If you pass a vertical line through it, it will only hit it once. But it fails the horizontal line test. So let's look at some functions that do pass the horizontal line test. Let's look at x cubed. This is a one-to-one function. Let's multiply it by -1. This is a one-to-one function. What you'll find about the domains of one-to-one functions is that they are either increasing or decreasing throughout the domain. Now, that's a small subset of the set of functions, so we want to be able to define the inverses of functions that may not be increasing or decreasing everywhere. So, to that end, we have domain restrictions. We only consider some subset of the domain so that we can invert it on that domain. Okay, so here I have a function and with some domain restrictions. That's a little more complicated. In blue, we have a small portion of the cosine function. Now, if we were to remove the domain restriction, the cosine function would not be a one-to-one function. But with this domain restriction, we see that it is. If I pass a horizontal line through any point, I only hit this function once. Now I'm going to show you that if I take away the domain restriction, the cosine function is most definitely not a one-to-one function. It oscillates continuously. There are any number of x's that hit, for example, 1. This function is 1 at 0, it's 1 at -2 pi, -4 pi. So this is not a one-to-one function, but if we introduce the domain restriction, you can see that, hey, well look, here we got this section of the cosine, and here we have the arc cosine, which is its inverse, and they are symmetric about y equals x. So we took a small chunk of this function and inverted it. So domain restrictions are how we work with the invertibility problem. So here we have another graph of y equals x squared and its inverse, the square root of x. Okay, so here it looks like, hey, if you just reflected the whole thing, you'd get this thing. But this isn't a function. It does not pass the vertical line test. For x equals 5, it has two values of y. Well, a function can only have one value of y for any value of x. So you can see all over the domain it fails the vertical line test. So that inverse is not a function. So again, we have to have a one-to-one function in order to invert it. Okay, so here they're asking, is y equals the absolute value of x a one-to-one function? Well, we sort of went over that. Okay. We take a look at this. Well, it fails the horizontal line test. So for instance, at x equals pi, you're about 3. And at x equals negative pi, you're at about 3. So here they're making abundantly clear that this is not a one-to-one function. So now they're introducing domain restrictions. Hey, if we only consider the positive part of y equals x squared, then we can consider it as having a rigorous inverse. Okay, you should be ready to do the end of this student activity sheet.